Ladies and gentlemen, please welcome SolidWorks Vice President of User Experience and Product Portfolio Management, Aaron Kelly.
Yesterday, I think we had a fantastic general session. Let's just recap. Bernard came up, gave us a pretty good vision. The thing that I took away from there is kind of his last line, or one of his last lines. It's only the beginning. You know, what we're working on now is going to help you in the future. You can be assured of that. Bertrand came up. My takeaway from Bertrand also was about investing today. We have the ability to invest in the products today and at the same time invest in the products for your future. We had a fantastic demonstration by my friend Kishore Boyalakuntala. Say that 5 times fast. But Kishore did a great job showing us our next generation product on the 3D Experience platform. And the R&D team, which we have to thank, let us show you a sneak preview of SolidWorks Industrial Conceptual, which is really hot, really cool. Next was Hugh Herr. Wow. I was kind of speechless after I watched it. I snuck out from out back and I made sure I came in the audience, and I was just listening to him and just amazed how articulate he is, how funny he was, and inspiring he was. So that was wonderful. In fact, there was a couple of the Twitters or tweets. This is how uncool I am. I have no real idea about the Twitterverse. I have an account. I think I've tweeted a couple of things, but I commit that I'm going to learn the power of Twitter. But if we look at some of the tweets, pretty cool. Kim Douglas, I'm in the transportation business. Instead of building cars, I build body parts. Hugh Herr, I thought that was pretty cool. Chin Lu, a lot of people here know Chin Lu. Imagine a future where we can heal a person completely with technology. Imagine. I mean, when I was thinking about the power of the 5,600 people here, the impact on the world that this special group of people have is pretty amazing. It's actually pretty amazing. Whether it's sustainability and it's sustaining the world, or making fast cars, or making complex things simple, this is a group that can deliver that and change the world. And Scott Burns. Scott Burns is a friend of mine. I know Scott. Scott's out here somewhere, I'm sure. 14th year attending. Hugh Herr was one of my favorite speakers ever, and I agree. Fantastic. Now, last night, I had the pleasure or displeasure of walking around the town. And I say displeasure because this is a big, big city. I have to learn about these yellow cars that drive around with lights on them and flag them down so I don't have to walk so far. But I walked a lot last night, and one of the things that I think is pretty easy to tell is that SolidWorks World has taken over San Diego. There's a restaurant every 10 feet. And as I was walking down the street, I'd be looking in these restaurants, and I'd see the badges. And I'd say, yeah, that person's from SolidWorks World. That person's from SolidWorks World. So hopefully, lots of you are out there spending your money. The mayor called from San Diego and thanks us all for spending our yen, kroner, euro, and dollars in this fine city. We are going to talk about customers today. We have some amazing customer stories. And we're going to get into it right now. To introduce our first customer is a gentleman that's been with DS for over 20 years. This is a person with an infectious personality. Try to find a time where this guy isn't cornering someone and talking to them. And I bet you he will have more business cards in his pocket at the end of this conference than anyone else. Direct from El Torito, please welcome the Vice President of User Advocacy and Strategy, Mr. Suchit Jain.
You had to say that about the El Torito, huh? Okay, only the San Diego and Los Angeles area people will understand that. Well, good morning. So yesterday, we all were wowed by the Mondo Spider up on stage, the same design you see up here. Now, it's designed by an organization called Eat Art Foundation. It's an educational charity which fosters art research and energy awareness by focusing on very large-scale, technically sophisticated projects. Well, it's my pleasure to welcome one of the co-founders of Eat Art, Jonathan Tippett. Jonathan. Hey.
Hey,
So that was quite an entrance yesterday, huh? You liked it?
Oh yeah, it was great.
Okay, so EDART all started with the idea of creating a walking machine, which is the Mondo Spider now.
Yeah.
Tell us all about that.
Well, it actually started with a junkyard wars style competition that my friends and I put on every year, and we invent an arbitrary challenge. And back in 2005, the challenge was to build a walking machine. So we cobbled together materials from just around the city, and we built this thing out of bike parts and door hinges, and it walked, I think, about 20 steps. We came second place out of 3, mind you. But it sort of galvanized the team.
So were there any design or material restrictions during the competition, or whatever you could get your hands on?
Both, really. Well, the major restriction was whatever you could get your hands on. So it was gentleman's rules. You couldn't throw out your lawnmower and then say, oh, I found a lawnmower. It was anything out of a scrap heap or a junkyard or a back alley. And we had 2 weeks to scrounge this material. And then we had 48 hours to bring it all with our tools. And then we had this feverish build. And we produced this machine that worked, but we thought, well, we're all engineers, and a lot of us go to Burning Man, and we thought, well, why don't we put our heads together, model this thing up in SolidWorks properly and design it, and then we can take it to Burning Man. So we took it to Burning Man, and that's when it ran into Daisy, the 3.5-ton solar-powered tricycle. And these two machines sort of met and fell in love, and the result was Eat Art. And so we formed a charity around these kinds of machines and these kinds of projects.
So that's interesting. I know energy awareness is very important to Eat Art. Why is it important to you?
Well, as I said, most of us are engineers, so we have a sort of a technical background, and we recognize that one of the most pressing matters coming up in the next few decades is going to be energy and how it's produced, how it's used. And one of the problems is that people aren't necessarily aware of how much energy is used for a given thing or where it comes from. So we wanted to introduce the conversation in a more sort of playful and innovative way by making these giant art projects. We take them to schools and science fairs and stuff.
So tell us about what other projects has Eat Art developed?
Well, there's been a bunch over the years, actually. We were founded in 2007. One of our first ones was called Container. It's a giant mobile solar-powered movie theater. Well, I guess for a movie theater, it's kind of small. But it's comprised of 2 40-foot containers that are stacked on top of each other, and inside there's a viewing screen and solar array on top. And then, of course, Daisy's one of our sort of signature pieces. She's one of the founding members, if you will. She's got a solar array that powers her completely off the grid, and she seats about 8 people, and she's basically a mobile lounge. Titanoboa is one of our most remarkable projects. It's being built by a fellow named Charlie Brinson, who's one of the guys who built the Spider with us. And he calls it a 50-foot-long electromechanical reincarnation of a serpent rendered extinct by climate change. So it's sort of symbolic of what kind of dangers may lay ahead if we don't pay it some attention. And then there's a group we call the G-Bikes, which stands for generator bikes, and they do all manner of pedal-powered contrivance. Their signature piece is the Black Ghost, which is a 4-person pedal-powered bike car. It's got a lithium-ion battery pack, and you can pull that up to an event, put it on jacks, and then the riders can generate power with it. Grammar Rail was another piece that we sponsored. It's a sort of a whimsical play on the whole notion of rail transport. So you've got 4 people pedaling around this giant gramophone, kind of good for theatrics. And then one of our more provocative pieces is Quick Fix. Quick Fix is a giant hypodermic needle made out of 3 oil barrels that we take and we deploy it, we jam it into the V8 engine of our truck that we are forced to use to tow our art around, and it symbolizes our addiction to fossil fuels.
Right. So as we see, all these creations are massive, right? They're very involved, I assume. So what is the design process like?
It varies, but it always starts with a vision. Somebody has an idea. I want to build a giant snake. I want to build a giant walking machine. And then around that vision forms a team. All of us are volunteers. Most of us are professional engineers and fabricators. So the team will kind of take shape, and then we'll sponsor student projects. So we'll go to our University of British Columbia, where I graduated, and we'll sort of carve off a portion of the project, and we'll get student input, and kind of like fine-tune it that way. And there's always a sort of a mixing and melding of specialties. There's electrical engineers, mechanical engineers. We've got software engineers. We even have a video game designer on our team.
So a lot of engineers. Huh?
Yeah.
Lot of engineers working together from a lot of different disciplines, collaboration happening. So how do they work together?
Well, different challenges require different types of collaboration. Electrical, you've got a schematic. Hydraulics, you've got maybe a schematic. I'm a mechanical engineer, and I come from a sculptural background, so I'm all about the shape and the form. The SolidWorks is my play area. So, we'll share models and have sort of meetings, and somebody's always an expert in whatever problem might have come up. That's the great thing about the team.
You know what, we heard about SolidWorks mechanical conceptual yesterday here, right?
Yeah.
It was about conceptual, it was about collaboration. I see a great fit between what you're doing and how it can help. What do you think?
That was exciting. It's like Google Docs for 3D CAD. It was amazing. It was unbelievable to see two people working on the same model.
Google Docs for 3D CAD, I like that. So listen, I know this audience really want to know about the Mondo Spider. Before the show started, you saw everybody out there. So let's walk up there.
Sure.
We'll talk about it a little bit.
Yeah.
As we are walking, I had a question for you. So how did you really get into this,
Well, I mean, when I was a kid, it was plasticine and Lego. I would make dinosaurs and superheroes out of plasticine and spaceships out of Lego. And that just kind of stuck with me. I was heavily into radio-controlled cars, and then eventually got an engineering degree and started building giant robots.
Right. So you built this, you designed this in SolidWorks.
Yeah.
How did you build it? How do you make it?
Well, that was kind of the trick, because none of the people on the team really had much experience in metal fabrication.
Yep.
So we were able to leverage the CAD data by taking the tubes virtually and splitting them and rolling them out and printing like full-scale templates. So you wrap the paper template around the tube, you hand your volunteer an angle grinder and a beer and a stack of tubes with paper wrapped around them, and you say repeat 8, 16, 32 times. And we actually got, all these legs were made by people with very little experience, and they came together just like Lego because we had these accurate templates. And then water jet cutting was the way we made the rest of it.
Right, and then you had something about creating a machine, or designing in SolidWorks, and
Yeah, well, the tube cutting process was great, and it's really gratifying to be able to give an unseasoned volunteer some work to do. But I wanted to sort of graduate all of my angle grinding team onto welding.
Yep.
So I built a CNC-controlled tubing cutter that uses a plasma torch head and just like open loop stepper controls, and I designed the whole thing on SolidWorks, and it sort of folds up and lives in the back of the shop.
So wait, and I want people to hear this. You use SolidWorks to design a machine, so you could use SolidWorks to build another one. But
Yeah.
that's pretty cool. What do you guys think? Yeah. Now, I'm here. Spider is here. You are here. Can I ride it?
Yeah, we get that a lot. We have a rule. We do have a rule that only those who built the Spider get to operate the Spider. But you could ride it in here because it's electric powered. In 2010, we converted it from gas to electric so that we could operate it indoors and so that we could sort of walk the walk, so to speak, in terms of new energy. So it's got a 48-volt lithium-ion pack. And the conversion was really simple comparatively because we had the whole thing modeled in SolidWorks already. And so we were able to squeeze in the battery packs, take out the gas engine, put in all the motors and motor controllers, and we were able to build the entire thing virtually before we cut any metal. So when we water cut the parts and welded it all together, we left the gas tank because it'd look a little silly without its abdomen on, but it's vestigial now. But the whole thing took about 6 weeks to build, to convert to electric.
So I think the audience will be able to look at it more closely, after this session.
Yeah.
Now, I can't ride this. I know we'll see about that.
Yeah.
You guys are here. I see that. Let's talk about that. What's that?
I might let you operate that because it's not actually connected to the machine that it controls. That is a third-generation exoskeletal interface for my next project, which is called Prosthesis the Anti-Robot. So you sit in here, kind of strap yourself in, and there's interlocks on the interface that activate it when you put your hand in.
You need any help there?
No, but If you lift up those cylinders, you'll see that they're moving with the arm. So this is to control one giant robotic leg, which is a prototype for a 2-story tall wearable walking machine that we're building. It's called an anti-robot because it has no autonomy. It has no capacity to sense its environment or walk or even stand by itself. So it's basically a sports machine. I call it a sports robot. And this was done for the early prototype.
So I see, I mean, you know, you're putting a lot of effort in there to move this. Is this how it would be?
Well, no, this is like having your power steering turned off, basically, because when those are in the machine will have a 350 kilowatt electric power pack that will actually do the heavy lifting. And this is just all the controls.
So how long is this project going?
The alpha leg, as we call it, this first prototype leg, has been under development for 3 years. And we've pretty much worked out all the bugs. We've got the control system sorted. We've got the power plant sorted out. We've got Arduino-controlled pumps giving flow on demand. And there's probably about 2 years to go before we finish the final machine.
That's a long time.
Yeah.
That's a long. So, you know, that's a long time. Where does the funding come from? Where's the money coming from for all this?
Well, that's a very good question. Mostly from my retirement fund so far. You know, we get support from sponsors in terms of components, and of course SolidWorks has been great with the software, but we're actually doing a crowdfunding campaign to finish prosthesis. If you go to Indiegogo and you check out, you just punch in anti-robot, you'll see our campaign. You can get yourself a sticker or a beer cup or something.
That's passion, right? So this audience can't wait to see what more Eat Art develops in future.
It's coming down the pike.
Right. So I also understand that you have another one of your co-founders here today among us.
We got Lee Christie here in the front row. Lee Christie was he actually ran the Mondo Spider project and was one of the very first Eat Art founders. And Cole Crocker sitting next to him, he started out as a student, and now he's like my right-hand man. I call him the hydraulics whisperer.
Jonathan, thank you for sharing with us at SolidWorks World, you know, all the stuff you do with SolidWorks and all the manufacturing and everything else. And hopefully, one day I will get that ride with the Mondo Spider. Maybe before the show closes. Please.
Oh, yeah. Well, now that the show's over, we can maybe afford to break it.
Oh, there you go. Thanks, Jonathan.
Yeah, my pleasure.
Thanks. Jonathan, fantastic. Thank you. What do you think of that? That's amazing. Hey, how many people remember last year when we had the bird flying around? Yeah, that was awesome, huh? Now we get the spider. How about next year we bring them both together on stage and see what happens? Fight it out. Yeah, that would be awesome. Okay, our sponsors are what makes SolidWorks World possible. And HP is a fantastic partner of ours. They've been a partner for a long time. They have fantastic technology. You really need to understand what they're about. Please make it a point to talk to them. But in the meantime, why don't we roll a short video from HP?
There are a lot of companies looking at how to put people up into space. There aren't a lot of people looking at how to bring them back down. Our goal was to set a record with Felix Baumgartner being the first person to break the speed of sound without the use of a vehicle. How do you bring people back from high altitude egress? It's designing a space capsule to withstand the hostile environment.
HP Z workstations with the new NVIDIA Quadro Kepler architecture and SolidWorks 2014. We can now simulate our projects much faster than ever before.
It gives us that rapid prototyping ability that smaller organizations now can do very quickly. We use the HP ZBook mobile workstation to scan the person in the suit. The HP Z workstation is able to process the computational fluid dynamics of what's going to happen during that free fall. Utilizing SolidWorks, we're able to interact with how all this assembly works together without breaking the thought process. How do we reach further and actually accomplish all these things that we dream about for so many years? Faster processing, faster graphics, it just gets easier.
All right. Thank you, HP, for being a platinum sponsor again. Thank you very much. Okay, in the next segment, we're going to talk about beta users. So, how many people, show of hands, used SolidWorks 2014 beta this year? So quite a few of you. Excellent. In fact, there were over 17,000 people that registered and used SolidWorks 2014 beta, way more than we've had in the past. 50% more hours were used using SolidWorks 2014 beta. That's a big deal for us. Now, beta is about sharing. We give you a preview, early preview of the new functionality. You can check it out. You can share it, see how you're going to deploy it. In exchange for that, if you find something that can make the product better, let us know. Let us know. So it is making an impact on our product. Thank you for your impact. At this point, I want to announce the winners of the beta contest for 2014. And forgive me if I get some mispronunciations. We'll blame it on the mic, right? So the winners for the customer section. And these winners, there's some pretty good serious prizes here. Top prize was $1,500, right? So I know my 8-year-old son's going to be doing this summer for a summer job, $1,500. The first winner in the SolidWorks category is Bettina Walker. Let's just give them a round of applause. They're not going to be coming up. For simulation, Yoshihiro Dobashi. For EPDM, Masanobu Higashino. And for composer, Manuki Okano. Congratulations to the beta users, and thank you again for your feedback. It helps us. We actually have another category for our resellers. And the awards go to, for the top beta participants in the reseller category. For SolidWorks, Michael Malov. Thank you, Michael. Simulation, Andrei Alyamovsky. Thank you, Andrei. For EPDM, Charlie Saint. Charlie might be here. Thank you, Charlie, for having an easy to pronounce name. Composer, Ludmila Staroverova and Scott Woods. Fantastic, fantastic. Thank you again. Beta program is really important for us to get that early feedback that we can tune the product right before we ship it to everybody. Okay, I didn't do too bad on the pronunciations, or at least I faked it good enough. Next is our community of users, and we're going to talk about the user groups. User groups are a big part of what fuels the passion, I think, in the community, the overall SolidWorks community. There's no question. From San Diego to Bangalore, India, and representing over 29 countries, do I get that right, Richard? Over 29 countries, we have SolidWorks local user groups, led by passionate SolidWorks advocates around the world. And these are also avenues to learn about SolidWorks and to give feedback back to SolidWorks. And more to talk about the user groups and communities in general is a gentleman that's worked for or at SolidWorks for 10 years. He worked for SolidWorks even before we paid him. But just don't invite him to your poker game. Yeah, it happened to you too, huh? Don't invite him to your poker game. Please welcome on stage the customer advocate's advocate, Mr. Richard Doyle. Come on, Richard.
Thanks, Aaron.
Take it away, bud.
Hello, everybody. Hey, you know, the SolidWorks User Group Network had another great year. 14 new chapters joined our family. And, you know, it just dawned on me yesterday, that's over one a month. That's pretty cool. We also had several groups that had been struggling that were resurrected by some energetic SolidWorks users. Guys like my new buddies, RJ Lynn in Charlotte and Matthew Stevenson up in Bakersfield took care of a couple of those for us. Thanks, guys. And we also had 800 SolidWorks users attend our one-day SWGN Technical Summit events. In fact, we set new attendance records in Chicago, Minneapolis, and State College, Pennsylvania. Yesterday, we had our 15th annual SWGN Summit meeting here at SolidWorks World, and I got to hang out with a lot of the people that really make this happen. And it's these folks right over here. It's our SWGN committee members and our user group leaders. Let's get them to stand up so we can give them a big old round of applause. Yesterday, we looked back at the SWGN Summit meeting. We looked back fondly over the past 15 years. We had some laughs. We had a couple of people cry, right, Eric? and me. And we heard from some special guests. Thank you, Bertrand. Thank you, John Paulo, Ken, Rich Allen. And we gave out some awards to our deserving reseller and partner companies that support user groups unconditionally throughout the year. And we'd like to congratulate 3D Vision Technologies and the Rapid Group, our Reseller and Partner of the Year Award. In 2014, we're going to continue to expand the network, and we're going to put a focus on international groups this year. So if you're a SolidWorks user in Portugal or Italy or Turkey or any of the other countries that are currently underserved by SolidWorks user groups, give us a shout and we'll help you get things going. We have SWGN committee members from around the world. They're here to help as well. And yesterday at the SWGN Summit meeting, my good friend and our CEO, Bertrand Sicot, made this statement in front of more than 100 people. He said later this year, he and I are going to be joined at the hip. So I'll be coming to see some of you folks as well. Now, with this many user group leaders and user groups, it's always hard to pick our SWGN award winners. If you ask my opinion, every single one of them deserves the award. But since we named it of the year, it kind of just makes sense that only one group and one person gets to win it each and every year. Our user group of the year this year has been around for 18 years and is still going strong. They have monthly meetings and some really outstanding technical content at those meetings. I was lucky enough, along with Aaron Kelly, last August to attend their 200th meeting since they have been in existence. And that's a record that's going to be really hard for some of you folks to catch. So keep having those meetings, okay? On top of all of that, the gentleman that's been leading this group for so many years is one of a handful, maybe a half a dozen SolidWorks users, SolidWorks customers that have been to every single SolidWorks user conference since 1999. And he's the only SolidWorks customer that has presented at every single SolidWorks conference. So let's get Phil Sluter and Jim Boland up here to accept the award, the User Group of the Year, the San Diego SolidWorks User Group. Congratulations, guys. Take that, Phil. You betcha. Congratulations. Each year we present the User Group Leader of the Award, User Group Leader of the Year Award in memory of our friend Wayne Tiffany. And the winner of that award is very often somebody that channels the same kind of passion that Wayne showed for the SolidWorks community. This year's winner is no exception. He leads one of the oldest and most respected user groups in the world, consistently travels around to other SolidWorks events to promote his user group and to promote the user group community. He's an active participant in the SolidWorks forums, and frankly, he's about the nicest guy I've ever met in my life. Please congratulate the 2013 User Group Leader of the Year, Jeff Holliday. There you go, buddy. Congratulations. Thank you very much. All right. Forgot my tissues this year. All right, let's get one more person up here to receive our special Michelle Pillars Community Award. Again, honoring one of our original founders of the SolidWorks User Group Network. And we look for the person out in the SolidWorks community, not necessarily restricted to our user group community, but that encompasses the entire SolidWorks community, from blogs to Twitter, 3D content central to the forums. It's that one special individual that we look for each and every year. We've picked a good one this year, somebody that a lot of you are going to recognize. He's always cheerful, always helpful. And as far as I can tell, he's always around 24/7. You can find this man doing something related to SolidWorks and the SolidWorks community. Let's bring him up here, our Michelle Pillars Community Award winner, Deepak Gupta. Congratulations,
Deepak. There you go.
I love making people smile. Hey, congratulations to all of our award winners, our user group leader, our user group, our Michelle Pillars Community Award winner, and thank you again to our partner and reseller winners. We had a great year. We're looking forward to another great year. I'm excited to get out and see a lot of you this year. So I look forward to seeing you at a local user group meeting or one of our Swuggen Technical Summit events. Thank you very much, everybody.
Thanks, buddy. Thank you very much. User groups, they're all around the world. How many people belong to a local user group? Show of hands. We can do better than that. We can do much better than that. Please, you can find all the information about user groups on the website. I absolutely recommend that you check out the local user group. This is where you can find out information. You can share information. They're kind of like mini SolidWorks Worlds, if you will. Meet once a month, once a quarter, all around the world. They're fantastic. I try to go to as many as I can. I learn a lot. It's a great way to interact and network. Okay, the next segment we have is another customer. I had the privilege of meeting this customer previous, but we're going to bring up somebody else to talk to them, a gentleman that I've known for a few years. I saw him backstage, and he was practicing his, most of us would practice our voice when we talk. This gentleman was practicing his hands, and you'll know in a minute why. He's the leader of our R&D team. He's in charge of literally dozens of our products. He weighs innovation with enhancements and problem resolutions. It's a very difficult job. He's a passion for our products, and it absolutely clearly shows. Please join me in welcoming the VP of R&D for SolidWorks, Mr. Gianpaolo Bassi. Hey.
Thank you, Aaron. So I was practicing with my hands. Okay, I will try to keep them steady. So good morning, everybody. I hope you all enjoy SolidWorks World as much as I do. At SolidWorks, we take a lot of pride and satisfaction at the introduction of new companies, new products, new technologies that were invented also with the help of SolidWorks design and simulation tools. Today, we have yet another one of these companies, a new inventor whose dreams and imagination have been helped also by the use of our software, of SolidWorks tools. So please help me welcome Greg Mark of Mark Forged.
Hey.
Hi, Greg. It's
good
nice to see you again.
Good to see you again,
Have you ever been in front of 6,000 people?
6,000?
Yeah, pretty powerful, huh?
Pretty exciting.
You have two names, Greg, Mark, so I may get confused from time to time. I can call you Greg, I can call you Mark. I hope you forgive me.
I'll respond to either.
Okay. Okay, Greg, Mark, Greg. So what is this about? I was blown away by your product. This is a first. So please tell us what this is about.
So we have the world's first 3D printer that prints in carbon fiber. And what this means is that you get parts that are 20 times stiffer and 5 times stronger than nylon plastic, which put another way means that you can print parts at your desk with a higher strength to weight ratio than CNC aluminum.
So, ladies and gentlemen, the world's first carbon fiber printer. Wow, interesting.
So do you want to see how it works?
Yeah, please. Beautiful. This is a first too. Beethoven to introduce a new technology. We hear a lot of techno music, but these kids appreciate Beethoven. That's very promising. I try again with my kids. I try again with my kids. So this is very, very beautiful. So what kind of products can you make with this printer?
So first, let's talk about the materials. So we have 2 print heads in the machine, and one of the print heads is nylon, and it's kind of a standard 3D printing material.
Okay, so this is nylon, very light, but I can bend it very easily, as you can see.
And then we have this second print head, and this is where the magic happens. This is the, oh, he's going to steal my sample.
Yeah.
This is where we print the carbon fiber, and as you can feel.
Okay, so same size, close to same weight, but extremely strong. I can barely, actually I cannot even bend it. Very good. So what do you do with these materials?
So let's say you want to design a part for your Ferrari race car.
How do you know I have a Ferrari?
Italian, right?
All right. If only in my mind. Okay.
So the first thing you do is you want to test the fit and the form of the part. So like a normal 3D printer, you would print it in plastic, make sure that it fits correctly, and you iterate on the design until you get it right.
Okay, so this is for conceptual mostly, right?
Exactly.
So the form and fit mostly.
Yes, exactly.
Right? Still 100% nylon.
Yep.
Okay, very good. Then what?
Now you want to actually bolt this to your Ferrari so you can take it out on the track and everything stays in one place. Now what you do is you add that second material, that carbon fiber, inside the part, in the same part, and now you get a part that is both strong and fits correctly.
Okay, so again, same shape, but much stiffer, much stronger. I can't bend it. So I can see a few areas in this part. I don't know if you can see that, but there is a central area which is honeycomb type of layout. Then we see the carbon fiber, more or less around the periphery, which tells you that most of the stress will be there. My engineering background is popping up. And then you have nylon all over the rest of the part. Okay, very good. So very stiff, very light. So what is the percentage of material that you use there?
So this is about 90% nylon and 10% carbon fiber. And the way we have the software set up right now, you can drag the part in, and it automatically, there's an auto mode where it puts the carbon fiber toward the outside of the part. So it gives you a very high strength to weight ratio without using much carbon material.
How do you bring the part in for the design of the layout of the fibers?
So we design the part in SolidWorks, and then we kind of flush it out as an STL. We drop it into the program, and then it runs through a slicer. Okay. And the slicer has an automatic mode, which if you're new to composites, will just automatically put the material at the outsides of the part, but also has a manual mode so you can go in there and adjust each layer. If you're an aerospace engineer or a bit of a control freak, and you want to have everything exactly where you want it, there's that automatic mode. Okay,
so basically, this 3D printing is not only about creating a unique shape, it's also how you lay out the different materials that make up a composite. So this is new, and this is what we are working on, how to best design this type of parts. But when I was at engineering school, composite was really for high-end applications, for aerospace, automotive, racing cars,
Yes.
So this is an elite type of part, or?
That part you're holding would cost $27.
Oh, okay. I can afford it.
You can, yeah. Yes.
For my Ferrari.
For your Ferrari. Not the most expensive part on the Ferrari.
So what you're saying is that you are kind of popularizing the use of composites because it's so easy to manufacture them.
Yes, so the expense in composites traditionally has been both the material and the hand layup process. So you have to lay all the fiber in the molds, you have to infuse the resin, you trim it, you cut it, you glue it together. It's a lot of labor. And what we did is we took that idea of laying up composites, and then we took the mechanics of a 3D printer, and we combined them so that you push the button, and it does all the labor for you.
But if I well remember, composite had to do with the curing, with the, resin. I mean, it was very complicated. How do you do that?
So the traditional method of composites, what we've been doing for 60 or 70 years, uses these two-part epoxies that cure together. We've switched that to these new thermoplastics that have come out in the last 15 years. And these thermoplastics cure or cool down as you're printing. So when the part comes out of the printer, that's how it comes out, it's done.
Ready to go.
Ready to race.
Okay, fantastic. So Greg, how did you come up with the idea of a carbon fiber printer?
So in the last business, we founded this, oh, there it goes.
Oh, my Ferrari.
The last business came out of MIT, and we made these computer-controlled race car wings. I think we have a clip of it. And the race car wings are full carbon fiber. They're about 11.5 pounds, designed in SolidWorks. Here's a picture of the Ferrari you're going to get, sitting in a $42 million wind tunnel. It's on a treadmill that will do 180 miles an hour. And we'll move over to some footage of it on track. And here's that wing. It's all pre-preg carbon fiber. Right now it's popping up to give you more downforce, more stability. When you turn, it splits to transfer the weight to the inside wheel. Helps you carve turns a little faster. Braking again. Now it's going to pull onto the front straightaway, and when the car reaches 160 miles an hour, just like in Formula One, the wing will drop, the downforce goes down, the drag goes down, and you get to pull away from your friends.
Wow, fantastic. So what kind of performance can you squeeze out of a Ferrari with this equipment?
So on this track, this is a 2-minute lap, and when you put this wing onto it, you bolt it on. It's fully computer controlled, automatic. It shaves 2 seconds off that 2-minute lap.
2 seconds out of 2 minutes. Wow, that's the difference between winning and losing, huh?
First and last.
Fantastic, Greg. This is amazing. So you were creating those high performance parts. So you said, why cannot I build them right away, right?
Yes, and the wing worked great. It's a phenomenal tool, but building out of composites has traditionally been a real pain in the butt.
I know. So Greg, you know, as any entrepreneur knows, you have to get funding for your ideas. You have a good imagination, great vision, but how do you communicate this vision to, the venture capitalist community? Because, I've been through it myself, so it's hard. How did you do that?
So the first thing we did is we designed the print head in SolidWorks, and then we realized, we put the standard PowerPoint together to go talk to the venture capitalists, and we had one computer running the PowerPoint and one computer running SolidWorks. So when we get to the technology and explaining how this is going to work, we pull up the solid model and they can see how the material goes through. We can rotate the machine around. And as you guys all know, once you have it in CAD, it's basically done.
All right, very good. So basically you use SolidWorks to pitch your idea.
Yes, absolutely.
And that was really a good way of doing it. And you get your funding at the end, right?
Yes, you could be. In order to get the funding, people need to really see it and feel it and understand it. And that's how it helps to have that solid model.
Okay, very good, very good. And I guess those VCs heard about SolidWorks before. So if you were using such tools, you must have been a good visionary, right?
Yes, well, it's actually funny. The same company that funded SolidWorks way back when is the same company that funded us.
Okay, very good. So then you created your first pre-production model. So how long did it take? What did you do? How that process went through?
So it took us about 8 months, and what we did is we split into 2 teams. One team internally designed the print head, so how the materials would flow through and print. And then a second team, we subcontracted out some precision machine design guys, people who have PhDs from MIT in precision machine design. They use SolidWorks too. So we were able to collaborate and merge the models and speak the same language.
Okay, and how many iterations did you go through before coming up with before consolidating your ideas, basically?
Yeah. We went through a lot of iterations. We'll start talking about this kinematic coupling that we have, where you put the stage into the machine. We went through about 20 iterations on that.
20 iterations.
20 iterations.
20 iterations. So this is the reason why we're spending a lot of time with these new tools that try to address the early stage, the innovation, the iterations that you go through, the conceptual phase, right? You heard about it, Greg,
yeah.
right?
So yesterday I was sitting over there and they showed mechanical conceptual, and we were sitting there, I was like, man, instead of doing all the detailed designs for each iteration, it would have been nice to just put it in there, get kind of the form and the fit so you can see it, explain it, iterate on it, and then back when you pick the final design, after number 19, when you get number 20, flesh out all the details.
Beautiful. So next to your invention, you will make use of mechanical
It would have been
conception.
nice.
Okay, very good. But everybody can see that you have a lot of attention on the function, but also on the form of your product itself.
Yes.
It is beautiful.
Thank you.
How come you have a focus on the beauty part of the equation?
Well, we wanted to make something that was beautiful, that people would be happy to both print on and have sitting, at their desk. We didn't want to make something that was like the copier that hid in the corner and nobody wanted. So, our first version of the machine had this strong unibody, and it was strong, it was rigid, but it wasn't very pretty to look at. Yeah, it's the cube in the corner over there. So we got in touch with some industrial designers, and they sent us back the one on the right, this beautiful rendering, but they were, you know, it looked like it was machined from a single block of aluminum, right? So we looked at it, how are we going to make that? So we were going back and forth with the industrial designers, trying to converge their beautiful idea of how the machine should look from our initial starting point, and we kept going back and forth, and finally, in frustration, I told them, look, just download e-drawings, we'll send you the solid models, tell us exactly how much bigger you want it. No more, you know, passing back and forth pictures.
Okay, fantastic. So a lot of iteration with the industrial design community as well, right?
Yes.
So maybe next time you will have a tool to do all that integrated on the same platform, you know?
That would be nice.
Mechanical conceptual, industrial design conceptual.
Then we would have done it in 6 months.
Very good, very good. So you mentioned the snapping thing. What was your biggest engineering challenge in designing this machine?
So in this kinematic coupling, what it does is it, when you take that build stage out and you put it back in, we want it to have 10 micron repeatability. One of the difficulties in 3D printing is getting that stage level with the print head. So if you have this repeatability, every time you take it out to pull the part off, when you put it back in, it goes exactly in the same place within 10 microns. But those pieces, that kinematic coupling, was very, very difficult to design and a lot of design iterations.
Super high precision, 10 micron.
10 microns.
Repeatability.
Yeah.
Wow, this is amazing.
It's pretty cool.
It's very important to produce high performance parts. This is very interesting. So how do you plan production? Because you are in pre-production now, but you're planning production. You are going to sell millions of these, right?
I hope so. So we have the entire machine is modeled in SolidWorks, all the nuts and bolts and actuators. So we use that to generate the BOM, as many of you guys will too. And it's nice because you get that warm fuzzy feeling that every part that's modeled, as long as you have every part, you're not missing something. So all of our costing analysis was done through that BOM function as well.
Okay, so what were the first use that you saw this machine? What was it first used for?
This is really cool. So one of the early customers wanted to use it to make prosthetics, kind of like Hugh Herr, who we saw yesterday. And it's one of these same things where you have these organic shapes that you need to fit to a body part. And you get to prototype them a couple times in nylon, figure out the fit, make sure you get it correct. But then when you want to build, transition from that fit to this actual form and functional part, you add the carbon fiber. And now you print this part out that both fits correctly and is strong.
Fantastic. So your machines will improve our life. So this is part of our overarching vision, right? Machine that makes our life better, improve everybody's life. Fantastic. So you have a very functional machine, a very beautiful machine. So you don't want only, you don't want to provide very, highly performant tools to your customers. You want to give them something more of that, right? How do you call that?
Well, it's kind of the Italian philosophy. We wanted it to be high performance, but we wanted people to have a good experience when they use it. You know, when you pull that platform out, we wanted it to feel nice when it clicks back in. It's magnetically connected. We wanted it to be something that the using experience was very fun, and the parts came out very strong.
Okay, so are you putting it on your girlfriend's kitchen?
The prototype machine actually was named after her.
Oh, really? Oh, fantastic.
And she's trying to steal it, but...
This is a fantastic story, Greg. Best luck. Please, a round of applause for Greg Mark of Mark Ford.
Thank you.
Thank you, Greg.
It's a pleasure.
Thanks, Fred.
Thank you.
Thanks, GP.
Thank you.
Wow, wow. Every SolidWorks World, there's something that comes up that you never thought of. Big surprise. I remember visiting our friends at Mark Ford's last year. And one of the things it's going to be in my brain for many, many years, I walked in, I met a handful of their employees at the time in a very small shop, about the size of this stage. And they're in there working, passionate people. And I remember the image that I'm going to remember for years. They had their printer sitting on the table, and right next to the printer was a computer screen showing the SolidWorks model. And that was just an image that was just unbelievable to me, art to part. Fantastic. That's a printer that I might have to see if the wife will let that in the budget. That's pretty cool. I'd like to have one for my desktop too. Okay, Partner Pavilion. Segue. In fact, I noticed in the Partner Pavilion there's lots of 3D printing companies represented. And they all do something a little bit different. They all have different takes on it. So you need to go and visit all of them to understand which one's going to be best for your applications. In fact, there's lots of technology partners over there. Over 100 are represented in the Partner Pavilion. Please take the time. Go talk to them. They're here for you. They want to make you more successful. Understand what they're offering, what they're selling, and hopefully it'll give you a productivity advantage. Okay, our next sponsor, our next platinum sponsor is Intel. We're going to show a short video, a message from Intel, please. All right, thank you, Intel. I love the messages. The messages are something that we've been trying to convey as well. If you can think it, you can design it. Pretty powerful message. Pretty powerful message. Obviously, Intel is powering the computers that we're using every day. You can get an advantage. The faster the computer, the faster you can get your job done. So thank you, Intel, for being a platinum sponsor. Okay, in the last segment, we talked to a very passionate customer, and their printer worked with carbon fiber. And in the next segment, the product that's created by this customer uses carbon fiber as well. Next up is a customer using really cool materials and SolidWorks to get their products to the finish line. For those of you who think my boss, fantastic gentleman, one of the best people on the planet, a man near and dear to my heart, again, my boss, who think Bertrand looks pretty good. He looks really good, right? Look better than me. I think some of us are actually thinking he's going a little downhill. Let's take a look at the video.
You're about ready for your first ride? I am. I don't know what I have to expect, but it's just going to be fun. That I know. And you know, I told you it's the champagne of thrills. Oh, of course, yeah. We will drink champagne together tonight to celebrate this event. Yeah.
Good. 2 minutes for this one. 2 minutes.
Come in right behind him.
Just remember, if you start coming forward, just push yourself back up because you don't want to hit me in the head, okay?
Yeah, okay.
And last thing, smile for the camera, okay?
Yeah. Okay. Okay, we are ready. We go. Let's go. That's 40, 55 seconds. That's nice. That's nice. So far, so good. Go. That's just right away. Yeah, that's that. Go fast, stand on the road on the right.
I think we are ready for the gold medal. We need to practice a little bit. So we have 3 months before the Olympics, right? So there is a new team on the list, the SolidWorks team, with a sled designed with SolidWorks. And I hope that the American team will win the gold medal in Sochi for the Olympics.
Ladies and gentlemen, please welcome Bertrand Sico.
Hey, I look like a bobsled driver, right?
Yes, you do.
You like my headset? Gentlemen, please welcome Jeff Bodine and Bob Cuneo.
Thank you. Thank you.
So, I don't know if you know, but these 2 guys here, they are teaming up together for a long time, right? Designing nice cars, and now the sleds. Jeff Bodine was designed as one of the fastest NASCAR driver of the history, right?
Well,
and he won the Daytona 500 in 1986.
Yes.
And you know, a driver can go fast on a track only when the car is fast. And for that, you need a great engineer to help him. So Bob Cuneo is the guy who is always behind the scene, taking care of all the details you need for winning, right? We hope.
Definitely.
Okay, so Jeff, tell us, how can you come from the NASCAR to the bobsled?
Well, I tell people I fell down and hit my head, but actually, who's going to watch the Winter Olympics coming up here in a few weeks, and of course the bobsled race? Great. Fantastic. Gold medal time. Who's going to watch the Daytona 500? That's in just a few weeks also. Great. Unfortunately, they're on the same weekend, so I'm not sure I'm going to watch the bobsledding. But, you know, I got involved in racing when I was 5 years old, just a little go-kart. I kind of grew up in racing, had uncles that raced, so they taught me all of that. And it only took me 37 years to win the Daytona 500. Quite a while, but very fortunate that I did. A much different way I got into bobsledding. I was watching the '92 Winter Olympics on television, and our American athletes weren't doing very well. They were bouncing off all the walls, kind of like what we do in NASCAR. Yeah, if you watch, you notice I've hit a few walls in my career. And, but the announcer said maybe the reason why our American kids aren't doing well is they have to use and buy equipment from their competition. Well, in NASCAR, I've sold a lot of race cars to my competition. Oh, of course, I always sold them the best. No, never the best. You always keep the best, you sell them the worst. And that's what was happening to our bobsled athletes. They were getting the worst, the leftovers, the sleds that nobody wanted. And that's the main reason their performance was so bad. We had great athletes, but they just had bad equipment. So I went to Lake Placid and actually drove a bobsled, crazy, You rode. That's crazy enough.
It is very crazy, I can tell you.
But
That's a unique experience.
Driving is a lot better, but it's still crazy. And like NASCAR, I hit the wall, bent the frame about 6 inches to the left. And by that time of the day, I realized a few things. One, I couldn't be a bobsled athlete or driver. Too small, can't run fast enough, not strong enough. Yeah, I'm a little too old. So I said, but I figured out what our bobsledders needed, what our athletes needed. It was a better bobsled. So after I bent the frame on this bobsled, I looked at the kid that owned it. I said, well, Bruce, I guess I'll have to build you a bobsled. Whoa, you got to be careful what you say in this world, don't you? I went back to North Carolina to do some racing, and I said, well, I'm too busy. I'm racing every week. My pit crew, they're working on my cars, so I can race every week. Who am I going to get to build these bobsleds? I thought of this guy. We'd raced together back in the early days. We built cars together, very successful. I knew the ability, the talent that Bob Cuneo and his company, Chassis Dynamics, had. I had 100% confidence. If I called Bobby and he said yes to building a bobsled, it would succeed. It would be great. So I did call him, told him what I wanted. Actually, he told me what I was going to ask him. I said, how do you know that? I saw on ESPN you were up riding a bobsled. You want me to build you a bobsled, don't you? I said, please, please, yes, yes. I don't have time, please. And he said yes. He said, I agree with you. Our kids need a better bobsled. We want to do it. We want to work with you. Let's do it. And so, obviously, we did. It all worked out. It's ended up with Night Train 1 and 2. Night Train 1 won the Olympics in Vancouver. Hopefully, Night Train 2, yes. I have a ring to prove it.
So yeah, what is this ring?
If you want to come up and look at this ring, it's a gold medal ring from Vancouver. Oh, I have a Daytona 500 ring here also. Bobby has a ring from the World Championship bobsleds. So we have a lot of stuff you can look at, plus the sled. But now, when I get with Bobby, and I don't know why he says this, he tells everybody, I ruined his life. Can you believe that? He said, Bobby, did I really ruin your life?
Yeah. No, that's not the truth. He gave me a great opportunity, and of my engineering career, it's probably the greatest moment that I ever had was at the Olympics, when we had won medals, and hundreds of medals in World Cup. We had won World Championships. But to win the Olympics, that means you are the best in the world on that day. And that's an experience not everybody gets to have. So I really can thank Jeffrey for putting me in that position to have that experience and to meet a lot of great, great people from around the world, even some other engineers that are our competition that I've become friends with. And it's something that I'll take to my grave. Wonderful experience.
So we need to learn a little bit more about this sport. So when I tried, first of all, you have to be totally crazy to sit down in this kind of device. You take 5 Gs in the curves. It's outstanding. I can tell you, if you have the opportunity to try it one day in your life, just do it. But if you look about what it is, you have a driver, you have the sled itself, and you have the athletes. So a lot of parameters here. What is the most important?
Oh. Well, maybe Bobby can answer that better. In racing, you know, we have basically the same things involved: the driver, a crew, the equipment. And, of course, us drivers always say we're the most important part of the equation. But that's not true. If you don't have a great team, pit crew, you're going to lose. If you don't have a great car, you're going to lose. So very similar to bobsledding.
Yeah, it's an equation that requires everything to be perfect. We don't have an engine. The push athletes are the horsepower. So we have to have the best push athletes in the world. We have to have a driver that has most incredible reflexes that you could imagine, they can't even focus fast enough for those turns that come up. It amazes me that they do what they do. And then you have to have the entire team that maintains the sled, builds the sled, and I would say they're all equal parts. And the incredible thing, because we're dealing in hundredths of a second, the difference between winning and losing is a hundredth of a second. The sum of the whole actually has to be greater than the sum of the parts. It's not just good enough to have the perfect driver, the perfect team, the perfect sled. They all have to mesh well enough to be better than 100%, and that's how you win. And it's a process that requires a lot of dedication from everybody involved.
Let's speak a little bit about the design, because I discovered, like NASCAR, that bobsled, you have a big book of rules that you have to respect, right, to apply. How can you innovate and be ahead of the competition, knowing that you have a book of rules?
I happen to bring a NASCAR rule book, so if anyone out here would like to build a NASCAR, you can come up and take this book and have at it. It's not very thick, doesn't look like there's a lot of information in there, but they write really small. The print is very, so there is a lot of rules in it, a lot of regulations. Bobsledding has a much larger book because the print is bigger. But yeah, like NASCAR, there's parameters, there's templates, and actually, since we've been involved, Bobby has brought a lot of new technology into bobsledding that they never looked at, they never checked before. And we're really proud of that because there was countries, some teams that were fudging the rules a little bit, getting away with things. And now they can't do that, and it's a lot because of what Bobby has brought into the sport.
Yeah, so, tell us more about that, because how can you find, you know, the cracks and make sure that you can innovate, but staying in the rules?
Well, we actually look at a new rule as an opportunity. The more rules that are in the rule book, then there are more spaces between the rules. And every space between the rules is an opportunity. So you just study and study and study, and you think of the parameters that you need to, the challenges that you need to overcome to go faster, and you try to fit in between those spaces in the rule book to find a way to find another hundredth of a second here or there. So that's what gives us the opportunity to make an innovative change.
Now, when Bobby was the engineer on my race team, we designed a lot of parts for the team to make the car better. A lot of great things, braking systems and locating bars for the rear axle, a lot of other things, and they're in this rule book. They're not legal anymore. They didn't like them, but really they were good. The great thing is that a lot of things we did innovate and bring into the sport is still legal. They didn't outlaw them, so we're very proud of that.
You told me that, okay, you innovate, you have to keep the secret, but sometimes you have the other teams that are doing tricky things to try to know what you are doing, right?
Yeah, we're always being watched. We even found out from the German team that they were looking at my small company in Connecticut from satellites to see if they could see something entering and leaving the building.
It's only bobsledding.
They go to our vendors to ask vendors what products we buy. It's pretty amazing the extent that the bobsleigh community will go to learn how we think.
Yeah, that's competition. Huh? That's a lot of competition right there. So, you told me also that when you look at this sled, you know, from outside, the shape is very advanced, right? So how do you study the aerodynamics of the sled?
We do a lot of computational flow analysis and then integrate that with the actual wind tunnel time. In the wind tunnel, we not only verify the data that we've learned from the computation, but we also position the athletes, and we learn a lot about just how they have to ride in the sled. We play with helmets. We can't change the helmets. They have to use
We have a video running here.
Yeah, this was the construction of the sled, the carbon body. But we have to use production helmets that can be bought over the shelf, but we use a combination of helmets from many manufacturers to get the proper airflow. So there are a lot of things we learn in the wind tunnel to finalize the outer shape. But the inner mechanics of the sled are just as important as the body. Everybody thinks that that's just a shell with skis on it, but it's a pretty intricate mechanism. And somewhere in here we show some CAD drawings. You'll notice it looks pretty simple. There aren't many parts in it.
Yes. Yeah. Thank you for sharing a CAD model, but
we removed several hundred parts from those drawings before we brought it here.
But you don't want to show anybody. So.
Sorry, we couldn't show you how to build a bobsled. Top secret, but this is just like NASCAR. This is actually was a wind tunnel right next to the one we use in NASCAR in Mooresville, North Carolina. Much smaller for bobsleds, bicycles, and all that type of vehicle, but aerodynamics is important in racing. Some tracks you want a lot of downforce, some you want very little. Bobsledding, most of the time, you want no downforce, you want less drag. So the way you get the sled to handle on the different tracks is more through the suspension than the aerodynamics.
Yeah, you think about a 4-year period. So you know that the culmination of the 4-year period is the Olympics at a given venue. So for Vancouver, it was we knew it was going to become the fastest track on Earth. So we put
95 miles an hour top speed.
We put an extra emphasis in aerodynamics. Well, we had already optimized the aerodynamics. Sochi is a slower track, but
only 85.
Yeah, but very, very technical. There are 3 uphill sections, and if the driver isn't exactly in the right line when he enters those uphill sections, it scrubs off speed, and that will kill the time. So we put all of our emphasis this time into control and the actual physics within the chassis to make the sled more precise, to get them on the right line for these uphill sections. So every track you have to approach differently.
And how did you do that, Bobby? How did you happen to come up with all those designs?
Well, you see, when you design something like this, you have to go through many, many design iterations to come up to verify your idea. And when we used to have to do everything in 2D CAD, we would have to build a lot of models and check the kinematics with physical models and whatnot. When we began using SolidWorks, and this was actually hard for me to accept in the beginning, when we had a design in SolidWorks, it was an actual model. It's real. It may be in a computer screen, but it's real. And whatever you make it do within there is what it's going to do in actuality. So this saved us days and days and days of iterations and testing to come up with a final design that we were confident that would mechanically do what we thought was the right thing.
There is a season, right? This season we have first the World Cup, and then after in 2 weeks we will have the Olympics, right? Tell us more on how you manage a season. You are here, far away from where the team is racing. So I'm told that you have an engineer that is with the team, that is doing work while you are here. Tell us more about that.
Well, I mean, as you know, John, it's a cold weather sport. I live in Florida. I don't like the cold anymore. So, yeah, I don't go unless I mean, I love to go watch. It's amazing to watch these athletes, especially when there's a 4-man. They're huge athletes, very strong, muscular. They run and then they jump in that thing as it's going about 40 miles an hour down the track. So it's great to watch. If you ever can do that, I recommend it. But Bobby and I, we have a friend that doesn't mind the cold weather.
Yeah, we have an associate that we've worked with for, well, actually, he came to work for me originally when he was 15 years old, but he's a very, very famous fabricator, engineer. We call him Cheech. His real name is Jim Gardet, and he's our man in the field. And we sent him to SolidWorks School, and in fact, it was Modern Tech. Modern Tech was a supplier in North Carolina, and educated him in SolidWorks. And he reports to me every week from the field. We have actually been making modifications literally every single week. He reports to me, I design the new parts, we build the parts, we airship them over there, he installs them and tests them. And that's how we have developed the thing faster and faster week after week during the World Cup season. We had one situation, we had an unfortunate wreck in Winterberg, Germany, and the sled was damaged. And he emailed me that the damage to the cowling was too severe to fix in the field with what he had. So we had all the geometry in the CAD. We went to our carbon fiber expert. Cheech took pictures of the damaged area. We isolated the amount that needed a repair. We actually created a section of the sled with attachment points and even templates for the cutting. And in exactly 1 week from the wreck, the sled was exactly perfect again. And that was all done because we were able to all have SolidWorks and communicate within the system.
I was thinking, you know, when I was listening the presentation just before, you know, I saw Jeff, you know, looking at the Ferrari with the spoiler, and I was joking with Jeff. I told him maybe one day the sled will be 3D printed directly, right, with carbon fiber.
Yes, that would take some fun out of it.
Yeah. I think we have a good news to share with the people here, right? Because as I told you, this year we have the World Cup, and in 2 weeks we have the Olympics. So when was it? Last weekend?
Yes.
It was in Europe, right?
It was the culmination of the World Cup.
Yeah.
And we won in Königssee, Germany.
Well, actually, Steve and his team have won 7 races this year.
Yeah, and they have won the overall points championship for the year, which seeds them right up in front for the Olympics.
So that's great, right? So, you know, I met with the athletes. I was thinking I'm tall. I'm not tall at all when you are behind them, you know. So they are very, very big, right?
Very.
So when you try that sled, you know, you've seen on the video, we started, for my trial, we were seated. So it took a little bit of time to get in the sled. But what you have to realize is that the 4 athletes, right, they have to run for what, 5 seconds? 7 seconds?
They're about 5 seconds, and they're going over 20 miles an hour when they jump in.
And after that, they have to jump into this small, tiny piece of carbon fiber that you have here. Yeah. And I can tell you the spaces are very tight. How do they do that? Do they practice? How do they do that?
They practice all year long.
I can get in the back. It's easy. But the other athletes, they have to run and then jump and get in, and it's absolutely amazing to watch.
How do they practice a lot?
They practice all the time, yes. That's the thing they practice most. And they have coaches, speed coaches. They do, when they get in the sled, if they push, they could actually get a faster start if they push a little farther. But then when they get in, the speed of the sled is greater than them. So the act of getting in the sled slows it down. So there's a lot of training in knowing exactly when to get in so they don't put any negative forces into the sled.
And for you NASCAR fans, it's very similar to pit crews. Race teams have pit crew trainers for strength, but then for the way they move and get in and change the tires, put the fuel in. And back when I was racing, if you pulled a 18-second pit stop, that was absolutely fantastic. Today, for you race fans, you watch on TV, you realize they changed 4 tires, put 22 gallons of fuel in 13 seconds, sometimes 12 seconds. It's amazing how far they've come with what they do. And it's the same in bobsledding. These athletes are absolutely pros. They work at it very hard, and they're the experts.
Okay, so you have the World Cup. It's done. You won the World Cup. In 2 weeks, we have Sochi. How do you focus on the Olympics? What are the specifics of this track that you know already?
We just know that it's incredibly technical, and it's really a driver's track. The driver has to be able to put the sled in exactly right position in every corner to get the proper acceleration. And to do that, the sled has to allow him to do that. So that was our challenge.
And very similar to the last race they ran and won in Königsley. That was a very technical track. So going into Sochi, our team has momentum, they have confidence, we have confidence, and hopefully you'll all be watching.
I discovered that when you drive the sled, I was expecting a kind of steering wheel. Not at all. You are handling handles, and that's literally how you drive. So the driver is feeling, or is it looking at? What's the balance between that?
Well, this is a very interesting situation we had with Steve Holcomb, our driver. Normally, the drivers would drive just as a race car driver, where it's a eye-hand coordination. He sees the track and processes that information through his hands. Interestingly, Steve Holcomb had a vision problem. He was legally blind up until he won the Olympics. He could not see anything. He couldn't recognize me at this distance. So he learned to drive by feel. Fortunately, he found some great doctors who restored his sight, but now even though he can see, he is still driving by feel. So we had to make some special adaptations to our steering and our suspension to give him the maximum feel that he needs to do well.
So we wanted to have the team here, but as you can guess, you know, they are getting prepared for the Olympics in 2 weeks. So we find a way to have you meet with them. So let's see.
Steve Holcomb, what a weekend you had going into Sochi Olympics, but how important is your relationship with your mechanic on tour?
Oh, it's extremely important. You know, I'm constantly giving feedback to Cheech and how to figure out how to make this thing faster, what I'm feeling in the track, and how he can make the changes that I need in order to maintain the control of the sled that I need. Our relationship is great, and he's been essential in our victories this year.
Cheech, from the first days he went to Modern Tech School to learn how to that SolidWorks software to where you are now, unbelievable, huh?
Well, that just helps us make changes on the road whenever I can just call back to the engineer, Bob Cuneo, work with my company, CCC, where you can make it happen.
Back to Kurt Tomasevich, the veteran, the gold medal team. Tested this sled 8 months ago. It's been a long process, wind tunnel. How do you think this whole thing's melding?
Actually, I'd have to say it's been a short process. We'd like to, you know, the more time we have in this sled, the better. It's a great testament to Holcomb and Cheech as well, saying how much they've done in just 1 year.
You learn anything about the mechanical part of this sled in the last 6 months?
Have I learned anything? I've learned that Cheech knows exactly what he's doing, and Holcomb can drive just about anything. So we're in good hands, and Cheech has been instrumental in this process. And this is a big win for us, but also for our program and the mechanics that do all the hard work.
How does it make you feel when you get up in the morning knowing that these guys have done all that work for your sled?
Makes me feel great. Like I said, Holcomb's awesome, Cheech is awesome, and the sled's running very fast right now. We're very excited for Sochi.
Well, congratulations, Night Train, and we all wish you the best of luck in Sochi.
Oh, it looks colder. I'm getting cold. I got to put my jacket back on. Yeah, I'm a warm.
This is the team. This is the team that is going to race for the United States of America at the Olympics in Sochi. So I guess, how can we close this section? I think everybody here has to wish you the luck, and I'm sure in 2 weeks you can send us a picture of the team with the gold medal, right? What about that?
Definitely.
So, Jeff, Bob, thank you very much, and I'm sure a lot of people will go and watch the sled and speak with you. So thank you very much. Guys?
Thank you.
Thank you.
Thank you.
Thank you.
Oh, Bertrand. Thank you all. Thank you. What a fantastic story that was. Very thrilling. But you're not going to see me riding in one of those bobsleds. Not because I'm afraid of going fast around ice with the risk of hurting myself or worse. I just don't think I could pull off those skin-tight suits. But that was a great story. In fact, all three of the stories, all the customers and the interviews that we had were fantastic. What do you think of them? Yeah, they were great. I think what I learned is if you work hard, if you have passion, and if you have the right tools, you can do anything. In fact, I'm a little bit inspired as well. I told you, I admitted to you, right, it's our secret, that I was a little naive when it came to Twitter. And so I've been inspired. I've been watching all the tweets and stuff go by, and I want to do a tweet myself. But I need a little help. Are you willing to help me? All right. So what I want to do is I want to tweet out a picture of 5,600 of the best and brightest in the engineering community of the world. You want to help me? All right. So I just need some smiles. You in the back, a little to the left. There we go. And you know what? I'm going to do two because this room is so big. Fantastic. I'm going to tweet that out. And you guys, I guess you can retweet it. I don't know if I'm talking the right words, but you can retweet it and say you were there too. Awesome. Thank you very much. Okay. In the meantime, we're going to have lots of fun tonight. Tuesday, the second day, is always about the offsite event. And it's at the Embarcadero Park, which is right behind the convention center. That way, I believe. You need your badge and ID to get in. Badge ID, badge ID. Don't forget them because you're going to have to walk back to get it. All right? So with that, we'll wrap it up for the general session. I think we had a great time today. I want you to go out, have fun. Bertrand asked you to go meet 5 new people. You have 2 days left. The general session's over. Thank you very much. Have a great day. We'll see you tonight.